Welcome back. What we've seen in the first two videos in this Helidon Basics series is how to REST enable existing code, how to put appropriate security measures on that REST enabled code to control access to it. And also briefly, we've looked at application and request scope to understand when a classed instance will be created and used. What we're going to do now is we're going to go a little bit beyond that basic application and REST scope and have a look at how the whole dependency injection works. Coupled with that, we're also going to look at how to use the configuration and setup information so that you can inject information into your code to change the behavior. So first of all, let's go and look at dependency injection and so on. So as we kind of saw a little bit earlier on, Helidon framework uses something called CDI, which is the context dependency injection framework. This is a standard Java enterprise thing. The one that Helidon itself uses is something called Weld. Now, what that does is that will dynamically create and keep track of classes for you. So that means that you don't have to instantiate a class. It means that you don't have to worry about making sure you're using the right version of the class or the right instance of a class in the right place. And the very basics of that are the concept of application scope, which means that the framework will track and create a single instance of the class throughout the entire program, and also request scope, which means it will create a new instance of that class for each and every request. Now, the question is, what happens if that's not coming in as an external request? What happens if it's something you want to use inside your code? Well, provided your code itself is a class that's under the control of CDI, in other words, it's request or application scope, there are a couple of other types of scope as well, you can use CDI to do the injection of subclasses and subfields for you. That can be through things like constructors or other values. So what we're going to look at, first of all, is if we go and look at our minimum change class, we're going to say that this is an application scoped class. The reason for this is we're going to use this minimum change in several places. We're going to use it when we configure it and set it as part of the configuration aspects of the program, but we're also going to use it when we try and reserve stock, because that's where we actually check to see whether the right number of stock items, or at least the number of stock items above the minimum, is being reserved. Therefore, we need the same instance in all of those places. So if I set that to be application scoped, that means that the framework will automatically create instances for us now, and it will reuse this single instance wherever it's needed. Now, that's particularly important if something is request scoped. So if the class that uses it is request scoped, because you might have 20 or 30 or thousands of instances of that calling request scope class, or sharing the same underlying application scoped instance. So we've done that. Now let's have a look at how we would use it. So let's just save that file and we'll go and have a look at the configuration to start with. Now at the moment, what we're doing here is we are creating a new instance within our constructor. Now that's absolutely fine, but of course that means we're bypassing the framework. So what we're going to do is we're going to put another annotation on here. Now this is an annotation called @inject. Okay, and we can remove the creation of that class instance. Now, what the @inject annotation means is that when the dependency and injection framework fires up and creates an instance of this class, it'll look at all of the fields within the class and say, aha, I need to go and find my minimum change instance, and either inject the existing one or create a new instance, depending on what minimum change itself is. Okay, so that's now set that up to use that, and because minimum change is application scoped, this itself will be the one that is shared across all instances. We're also going to change this on the storefront resource, and there's going to be a slight difference here because the storefront resource is a request scoped class. So the question is, how does that work? Well, as I've said, this is a application scoped class in terms of minimum change. So there's only ever one of them according to the framework. Therefore, if I inject it, as I just did with the configuration resource, I'm injecting the same instance of a class, regardless of the fact that this itself is a request scope class. So you get a new instance of a storefront, but it will use the same shared minimum change instance. Okay, so let's save that. We'll stop this, save everything, and let's go and run this now. Okay, so our service is now up and running. And if we go and let's get the minimum change, as we would expect, that is a value of 3, because that's what the default value is. And you'll be thinking about how does the constructor work this out. We'll talk about how it works out the constructor to use in a moment. And what we're going to do now is we are going to try and request some stock. Okay, and we're going to request 2 items of stock. So hopefully our copy and paste will work. Come on. Sometimes technology really, really irritates me. I have no idea why this sometimes works and sometimes doesn't. There we go, did this time. So this is the standard request stock method. You can see that we're requesting a count of 2. Okay, so that, as would be expected, fails, and it fails because the minimum change is 3. So let's go and now change our, actually, no, let's just check to confirm. We will call this and we will actually request 3 items. So if I go back in here and I change our request to 3, it works because our minimum change is 3. So what we can do now is we can change what the minimum change value is. Oops. So let's go and take this. Okay. So in this case, you can see in the CURL, I'm specifying in the content data of 1. Now, we're not using a JSON object here because there's only a single field. So we don't need to worry about that. We could, of course, have created a JSON object which had a bit more data in it. So let's go and make that change, right? And if we now get the minimum change, so let's go and rerun that get minimum change command. Yep, that minimum change is 1. And now if I make the request to get the stock, okay, so I can now reserve stock and I'm going to reserve 2 items of stock. Could, of course, have reserved 1. You can see that this now succeeds. So effectively, what we've just seen is how to use the dependency injection system to dynamically inject either a new or a shared instance of an object, depending on whether that is an application or non-application scoped object. So that works really well. We can now change this. Brilliant. The trouble is, every time we restart our code, we are, of course, going, we create a new instance of minimum change when the whole application starts up, and by default, that has a value of 3. We don't want to be doing this every single time. So let's actually have a look at how we can change that. So this is probably not something that we want to access on a regular basis, but we do want to change our configuration. So first of all, what we're going to do is we're going to change the minimum change code. Okay. Now, by default, unless you specify otherwise, the system will use the 0args constructor. Okay. But what we can do is we can add a new constructor. So we are going to add a new constructor here. And we are going to tell that constructor, oops, that we want it to add or to set its value. Okay, no, missed the joy of the live recording. Okay, so we've got our constructor. It's got a integer minimum change value. Right, now let's say that actually this is the one we want to use when this method is instantiated. Now, unfortunately, the code or the standards use inject to say, I want this is to be injected. And also it uses inject to say, this is the call I want you to, or the constructor I want you to use when you are injecting. It's a really irritating overloading of a piece of code. But now we've got another question, which is, where does it get that value from? Well, Helidon has a configuration system. This is a very nice hierarchical configuration. It's incredibly powerful, as we'll see in a minute. And one of the things that you can do with this configuration system is you can store values in it that can be retrieved when the dependency and injection system goes and creates an object. So what we're going to do here is we're going to we'll put an annotation on our constructor that says, I want you to get the configuration property minimum.change and use that as the value for the initial minimum change argument when the code runs. Okay, so this may look a little bit complicated, but effectively what we've just done is we've moved this from being something that's hard coded in the application or something that you would have to set manually every time your application runs to something that is dynamically set for us based on configuration information. So let's go and run that now. So now if I access the minimum change, we're going to see a slightly different value. You can see here it's coming up with a value of 4. Well, where does that come from? Well, it comes from the configuration files. We're going to look at how those work in a little bit, but basically, the contents of a configuration file is read when Helidon starts up, and we specify what configuration files to read. Now, there are a number of ways that we can specify the configuration file, but what we're going to do here is we're going to actually code this into the program. Now, again, there's many ways of doing this. What you would probably do normally is you would do what's called a meta configuration file, which is basically a configuration file that specifies where all of the other configuration files are. And that gives you a lot more flexibility. Sounds a bit complicated, but it makes life a lot easier. Again, for the purposes of this lab, we're not doing that. We're doing this in a much simpler mechanism and a much more controlled mechanism. Okay, so therefore I need to say where that file comes from. Okay, so what I've got here is I've got in my main method a class that will go and create a method for me. So if I go and add this to the class, oops, there we go, let's just mostly format that. Effectively what I'm doing is I'm adding to the list of configuration sources something called /conf/storefront config.yaml. Okay. Now please notice that this is a optional class, or optional file. That means if it doesn't exist, the code will still run. If we hadn't got optional there and the code ran, then it would error. So that's a good way of ensuring that you do actually have the configuration files in place that you are expecting to see. So if we just have a look at what that is, if I go to the storefront.config, this is a YAML file, and you can see that it has been told to use 2 in there. Well, why 2? Because we had 4 earlier on, didn't we? Well, what actually happened is if we look at the main routine, you will see that there is another effectively further down in the stack. So it'll get used, or the contents of this will get used if a value has not already been set. And this is our config.properties file. Okay, so if we go and look at our main resource config properties file, this is, by the way, a Java properties file. There are many different formats that Helidon supports. The ones you tend to use are either properties or JSON or YAML, but there are others as well. And you can see here, by default, we set it to 4. Now that, of course, is built into the class path. What we've just done is we've just said, you can now use this external file that is configurable. If it's present, it will get read. And anything that's in there will override previous settings. So this is how you can ensure that your code always has valid default values without writing them into the code itself, but also provide a mechanism for overwriting those values when you need to. So let's just go and save that. Okay. Now, as I say, often you wouldn't use this by hand, you'd use the metaconfig system. And that basically just looks for a file, which is a metaconfig file. And again, in that scenario, you wouldn't need to use all of the main routines and so on to do that. So we're doing it because we want to control exactly what happens at each point in the lab, but that's not what you would do in a production system. So we're going to run that configuration file. We've loaded all of our classes. Okay, our service is running. So now if we go in and we pull that minimum change again, you can see the minimum change value is 2 now. And that's the value that we got from the higher level config file that we just included. Now, there is actually one other thing that we can do here. We can actually enhance the way this works. So at the moment, that config file is read when the code starts up. But what happens if this is something that we might want to change over time and we don't want to have to restart the code? Well, there are mechanisms within Helidon to support that. So let's go and have a look at that. So what we're going to do is we're going to add what's called a polling strategy. Now, a polling strategy is basically what it sounds, and it will let us look at the access to the system, or access to a file system. So in this case, we specified a polling strategy that every 5 seconds will check to see if the file has changed. Now, I've chosen 5 seconds for lab purposes. We don't want to be sitting around waiting for a while just to make a change. But in most cases, it's probably more likely to be 5 minutes than 5 seconds. But what we've now got is the ability to change this file and have that change dynamically reflected into the system. Okay. Now, just to be clear here, what we've just done won't work because our value is only used in the minimum change object when the class is instantiated. Because this is application scoped, we don't instantiate this class more than once, and that's obviously done when the code starts. But what we do have is we have our status endpoint, which we saw briefly in the previous lab. Now, the status endpoint, if we go and have a quick look at that, this is request scoped, so it's recreated every single time. And here you can see we have an inject method that tells us this is the method to use, or this is the constructor to use, and it's pulling a value called app.storename. So let's go and run that. Okay, so again, we're using the main method, or main class to do it. So let's go and access the status endpoint. Okay, and you can see it now says my shop. Okay, now just to be clear here, we actually have several layers of config that are being scanned and processed. In the microprofile properties, which is the default values that would be there every time you package it up into a jar file, you can see that the value here is not set for that method. Okay, so that's what will be used by default. However, in the storefront config file, we have specified app.storename is my shop. So effectively, we've overridden that. But I think I'd rather have this a little bit personalized. So what I'm going to do is I'm going to change this to Tim's shop. Okay, so I'm going to save that away. Now, if I go back to my code and access this again, you can see now that Helidon has recognized that that file has changed. And when we recreated the status resource object to respond to the status request, it used the new value of the configuration to inject it for us. So basically, what we've just done is shown how to handle configuration information without having a huge long list of arguments or environment variables, how to use that configuration values as part of the way the dependency injection system works. And finally, we've shown how we can update the configuration file and use that update to dynamically be reflected into the running code. So coming up, there's a little bit on how to get all of the underlying source code and templates that we've been using in the lab. Hopefully what you've just seen is useful and valuable. And what we're going to be doing in the next video in this series is we're going to have a look at how we would split administration functions from non-administration functions, and also how we would handle problems. Because as we saw earlier, if the code throws an error, you just get a 500 internal server error. We want to do a little bit better than that. So thank you for your time, and I look forward to seeing you in the next video in this series. What you've just seen is based on a lab, which goes through effectively using Helidon to create microservices from a monolith piece of code. This lab is available to anybody on the internet. It's originally written to work in the Oracle Cloud, but you can take the source code from the Git repository and run it in your own environment. You can use a MySQL database or other databases if you want to. So what I'm going to do now is quickly show you how to get to the lab. That will include links to where you can download the original template source code and obviously the content of the lab itself. So in a web browser, if you go to bit.ly/go live labs, okay, and that will take you to the Oracle Live Labs starting page. Then search for using Helidon to create microservices from a monolith. Now that's going to return two lab options. The overall sequence of videos is based on the extended lab version, but if you don't want to do the extended stuff, you can just focus on the shorter version. You basically just click the launch button. And then if you want to run it on an Oracle trial, you can register for free trial environment. If you already have a free trial environment, you can then look at running it within that environment. You just basically click on that. You can then have access to the web page. Effectively what you need to do, follow the instructions under getting started and set up your tenancy and set up for the Helidon labs to get this working in the Oracle Cloud environment. Now, if you don't want to use the Oracle Cloud environment, then there are instructions on how to download the source code using in the setup for Helidon labs section. You'll obviously need to make sure that you've got Java 11 on your laptop. You're going to need to make sure that you've got a suitable IDE and so on. If you want to use a database other than the Oracle database, you can do that, but you'll need to configure the database files so that you can ensure that it will work on the local database, and that's basically through the JDBC and JPA, JTA settings in the meta-inf folder. So thank you for that. Hopefully you will enjoy playing with that, and good luck.